my amazing students. This is Mrs. A with 6.4, and we're talking about multiplication of polynomials and polynomial functions. So, remember, this is the last section that will be on Tuesday's test. So I wanted to make sure I got it on here in plenty of time for you to review it. So we're going to start out with this one, and this is called monomial multiplication because we have just a single monomial term that we're going to multiply through another polynomial. And this is just a simple distribution. We're going to multiply the 4f squared by the first term, the second term, and the third term. Okay, so the first thing that we do is with the first term, 4 times a negative 3 is a negative 12. F squared times an f squared. Remember, when we add like bases, we multiply. No, excuse me. When we multiply like bases, we add the exponents. It's a little late. Okay, f to the, so we add them, f to the fourth. Okay, so we multiply like bases, we add their exponents. So then we move over to the second term over here, and we're going to get a 32 when we multiply the 4 and the 8, and f squared times f will be f cubed because I just add the square and the 1. When there's no exponent there, it is a 1. And the last one is times 1, so we're just going to copy 4f squared down. And that is all that we can do because remember, we cannot add any terms that are not like terms, and this is a fourth power and a third power and a square power, so we're done with that problem. The second problem that we're going to do is a little more complicated because it is a binomial times a trinomial. Okay, so we're going to do this type of problem two ways. First, we're going to do it horizontally, like we have it on the board. And I usually do problems this way simply because they're usually given to me this way. And so when we multiply this one times this one, and this one times this one, and this one times this one, then we're done with the 4x term, and then we're going to take the negative 2 term and multiply it by each term. Distribution is just making sure that you touch every single term in the second polynomial with the first terms in the first polynomial. So we have to multiply every term by every term in the other polynomial. So let's begin. So the first thing we're going to do is 4x times 2x squared. So 4x times 2x squared, so I'm going to multiply this term all the way across. So 4x times 2x squared is 8x cubed. And 4x times 3x is 12x squared. And 4x times a negative 4 is a negative 16x. So then a negative 2 times a 2x squared is a negative 4x squared. A negative 2 times a 3x. So we're done with this one, in other words. Now we're working on this one. Negative 2 gives me that. Negative 2 times the 3x gives me a negative 6x. Notice I'm putting them under the right columns here. And then the last one, negative times negative gives me a positive 8. Almost out of room on my board. So that's what I have so far. And I have a cubed column, a squared column, an x column, and a constant. So since 8x cubed doesn't have anything to add to, we just write them down. 12 minus 4 is 8. So it's a positive 8x squared. Negative 16 and negative 6 is a negative 22x plus 8. And since we have no like terms to combine together, we are through. We already did combine the like terms together, right? Okay, let's go to the next one. The next problem is a trinomial times a trinomial. So we're going to do the same process that we just did on the last one. And I'm going to take the 2a squared and I'm going to multiply it by each term in the second polynomial. So 2a squared times a cubed is going to be 2a to the fifth. I add the two exponents together, and then 2a squared times negative 2a squared will be negative 4a to the fourth, and then 2a squared times a 1 is 2a squared. Okay, so I've finished with this one right here. I'm done with it. Okay, so now we move to the a, the second term here. And a times a cubed is a to the fourth. And I'm going to put that here under my fourth column. And a times negative 2a squared is negative 2a cubed. And I'll put that right, oops, what did I do? I had a 2a squared and I did not leave a spot. Okay, so somewhere in here we have a little glitch. Can you see it? My housekeeping is not coming out very nicely, so let's find our glitch. Square, 1, 0. No problems there. Cubed, squared, no x term. We jumped to a constant. So I didn't see that at first, and that's why I had no spot for the cubic. So we're going to take this 2a squared. We're going to move it down a little bit. Okay, so now we just did a to the fourth, and this is negative 2a cubed. So now I've made a little cube spot here. Negative 2a cubed. Okay, and then I go to the next one, which is just an a. So I'm going to make my little a spot down here. There's a problem. I don't have a constant spot. I'm going to have to hang out my constant down at the bottom. What could I have done to make this come out a little prettier? Could I have put in a dummy variable like I did with the division? If I put in a dummy variable there, then I'm basically leaving a spot so that I would have had a 0x cubed here to hold the cubed spot. Okay, so now let's do the last one. We're done with the a. So now let's do the negative 3. Negative 3 times a cubed is negative 3a cubed. And I'll put it underneath the a cubed column. And negative 3 times negative 2 is 6a squared, because I have an a squared there. So 6a squared is positive, and I will put it right here in the a squared column. And then negative 3 times positive 4 is a negative 3. And I'm going to tuck it way down here because I don't want it to get it confused. Okay, so now we're going to add all of our terms together. And we have a 2a to the fifth minus, now we got a 4a4 and a 1a to the fourth. So we're going to wind up with a negative 3a to the fourth. Okay, and then we have cubes, a negative 2 and a negative 3a cubed for a negative 5a cubed. Right, so then we have our a squareds, and we have two positives on those, so we have 8a squared. And then we have a single a and a single minus 3. So that should be your answer. Okay, so now we stumbled through that and we managed to keep things lined up. But to fix this whole situation and make sure everything lines up nicely, you could put a, right here, you could put a 0a. You put a 0a right there, then it would have kept everything lined up. But I think that one might have been too big for my board. Okay, so let's move on to the next one. And now we're going to do a vertical where we're doing a trinomial times a binomial. Okay, and I like to do these to just the same way as I showed you in the classroom that you would do normal multiplication. You would multiply this one times this one, this one times this one, this one times this one. Okay, since we don't have any missing terms, we should come out okay here with everything lining up just the way it should. Okay, so 3 times negative 1, so we're doing the negative 1 first. 3 times negative 1 is negative 3. Negative 2x times negative 1 is positive 2x. And 5x squared times the negative 1 is negative 5x squared. Now I'm moving the x squared just a little bit over because I am going to have a cubic term when I finish because I have that 3x. Okay, so I'm leaving a little space there that I didn't remember to leave in the problem. Okay, so 3 times 3x, we're done with this one. 3 times 3x is 9x. And negative 2 times 3x is negative 6x squared. 5x squared times 3x is 15x cubed. And now we add them together. That was a positive. So now we have them lined up in the correct terms. You have like terms above each other. So negative 3, positive 11x, negative 11x squared, and 15x cubed. All right, so now we're ready to do a FOIL problem. Okay, FOIL problem first, outside, inside, last. And remember, when I showed you the FOIL problem on the board, I said the first two terms are the first terms in each parenthesis. That's your F for FOIL. Okay, your outside terms are the stand for the O, so they're the outside of each parenthesis. The inside terms are right here, and they're inside most on each parenthesis, and the last term is here. Okay, now of course the little picture is not that important, but my little FOIL man does help you remember the order. I think he's cute. But when you look at the little FOIL man, the ears are the outsides. And then right here at his nose, you see his nose, right on each side of his nose are the insides. And then we've got the first are his eyebrow, his left eyebrow, and the last would be his right eyebrow. Okay, so when we start to multiply, the first k times k is k squared. The outside, k times negative 7 is negative 7k. The inside is 10k. And the last is negative 70. The eyebrow there, negative 70. Notice that two of those terms are like terms, and we should finish adding them together. These two right here will go together, so we wind up getting a k squared, a 3k minus 70. And I'll be back with some more. All right, so we're back here with some more FOIL problems, which are binomial times binomial problems. Got to get situated. All right, so we've got the first, which will give us 6p squared. The outsides will give us negative 18p. The insides, by FOIL man's nose there, will be negative 5p. And then the last will be positive 15. Now these two will add together. So negative 18p plus negative 5p will be a negative 23p. So I'm just going to take that out and put in a negative 23p. And there we have the answer. All right, so let's do the second one here. We've got a squared. We're doing the first. We'll get a squared. We'll do the outside and get negative 8ab. Now this one is a little different because we have two variables, whereas this one we just had one variable. Okay, so now we've got the inside by his nose, which will be 2ab. Remember, it's 2ba, 2ab, it doesn't matter because multiplication is commutative. So plus 2ab, and then the last will be negative 16b squared. So negative 16b squared. Now when you look at that, I do have two terms that I can put together. So I'm going to combine them and get a squared minus 6ab, these two combined, minus 16b squared. Okay, that's the end of those problems. Let's look at the next one. The first one is a FOIL here, and we are going to have a hodgepodge because notice we have an X and a Y, and whereas in this one here we had an A and a B in both terms, in both parentheses, now we have two variables, but they're in different parentheses. So we're going to do it exactly the same way, but we're not going to get any terms that will add together at the end. So 5x times y is 5xy. The outside will be a 20x. The inside will be a 2y. And the last will be a positive 8. And we cannot combine any of those together any further because they're not like terms. All right, so now we did something like this on the board. We've got a monomial and two binomials. We're going to have to choose how we're going to do this. Generally, I will multiply my binomials together with a FOIL, and then I will distribute this one through that product. So we've got here, my FOIL here, 2f squared. And then my outside is 4f. And then my inside is negative f. And then my last will be a negative 2. Okay, so my 4f and my negative f will add together to give me a positive 3f. And now this whole thing is the simplified product of these two binomials. So now I'm going to bring down my monomial, and I'm going to distribute my monomial across my current product here. So 12 times 2, I'm going to multiply this one times this one. 12 times 2 is 24. F squared times f squared is f to the 4th. So 12f squared times 3f, moving to this one, is going to be 36. F squared times f is f cubed. And then again, we go all the way over here. 12f squared times negative 2 is negative 24f squared. And since we have no like terms, this would be our final answer. We've got a 4 power, 3 power, 2 power, and we are done with that one. Okay, our next one is a little more complicated. Don't you love the way they just grow in complication? I have 3 binomials to multiply together. So I'm going to do them just like I did the last problem. I'm going to, now it doesn't matter, I'm doing this for board space. I'm going to go ahead and multiply these 2 together, and then I'm going to distribute this one through this product. I could multiply those 2 together and then multiply that by this one, but just because of board space, I'm going to multiply these 2 back ones together. I'm going to slide them over just a little bit. So t, my first, will be t squared. My outside will be 6t. My inside is negative 1t. And my last will be negative 6. Okay? Now, again, I have like terms right in the middle that I'm going to go ahead and clean up. 6t minus 1t is 5t. So let's just go straight to 5t. And now this is the simplified product of these 2 binomials. So now I need to multiply this one all the way through here. So I'm going to bring it down, t plus 4, and I'm going to distribute, which means I'm going to take the t and make sure it touches each term with multiplication, and then I will take the 4 and make sure it goes to each term with multiplication. So let's first do the t, and t times t squared gives me a t cubed, and I'm going to put that over here because this is my highest degree term. I know that because I'm multiplying the highest degree term there and the highest degree term there, so t cubed is my highest degree term. Then I have t times 5t is 5t squared, and t times negative 6 is negative 6t. And now I've done all the multiplication I need to do with that t. So now I'm going to go to the 4, and I'm going to end up shifting in because I want my 4t squared here to wind up here. 4t squared in the t squared column. And 4 times 5t is going to be a 20t. And 4 times negative 6 is going to be negative 24. Constant. So now when I add all my like terms together, you see I've got my cubes, my squares, my t's, my constants, and I get a t cubed, and then a 9t squared, and then a 20 minus a 6, a 14t minus 24. And that's as simple as I can get that answer because they're all different terms. No like terms in this bottom one. Okay? Now we're going to talk about some special patterns in multiplication. And we call these here, all 3 of these are conjugates. And conjugates have the same terms, q, q, 4, 4, but opposite signs. 2, 2, x, x, opposite signs. 5m, 5m, 1, 1, opposite signs. Now the cool thing that happens with conjugates is that when I multiply them using my FOIL method, the inside and outside have the same value, different signs. So they will cancel each other out. So here we go. The first will be q squared. I'm just going to put it over here since it's so crowded. Q squared, and then a 4q, let's do the outside first because that's our pattern, minus 4q, and then our inside will be positive 4q, and then our last will be negative 16. So our negative 4q and our positive 4q are going to go away, and so cancel, cancel, and we end up with q squared minus 16. So I'll write that one a little bit prettier. Q squared minus 16 is the answer. Notice that the answer is a difference of 2 squares. Okay, so when you multiply conjugates, you always get a difference of 2 squares. And those 2 squares wind up being the first term squared minus the last term squared. First term squared minus the last term squared. Pretty cool. All right, so let's do this one. When we FOIL it, we're going to get 2 times 2 is 4. The outside is positive 2x. The inside is negative 2x. And the last is negative x squared. Now that's kind of backwards. Most of the time, I believe that your Connect Math will count this as correct, even though it's backwards, because you were given a backwards problem. Now, when I say backwards, that means it's not in descending order of the variable, and we could have rearranged it at the beginning, but I don't think they wanted to do that because that would have given you a negative x plus 2, which would have been awkward. Okay, so we got a 2x and a negative 2x. Those go away, and so our answer is 4 minus x squared. And again, it's a difference of 2 squares, and it's the first term squared, which is a 4, minus the last term squared, which is x squared. Okay, this last one here is going to be 5m times 5m, multiplying the first to get 25m squared. Outside is negative 5m. Inside is positive 5m. And the last is negative 1. Negative 1 squared is still 1. Okay, so our inside and our outside are going to cancel, leaving us with a 25m squared minus 1. A difference of 2 squares, and again, that's the first term squared minus the last term squared. So that is how you do conjugates. When you multiply conjugates, you always get a difference of 2 squares. Now, we're doing another type of special problem, which is squaring a binomial. Okay, now I'm going to show you the pattern for squaring a binomial right down here. If I take a plus b and I multiply it by itself, that's the same thing as a plus b squared. So we're going to just start there. A plus b. Now I'm using generic terms because I wanted the pattern that I developed to apply to all binomials squared. Okay, so I didn't use any specific numbers in it. So now when I multiply, when I FOIL, I get an a squared. I get the outsides multiplied to get an AB. The insides multiply to also give me an AB. And the last multiply to give me a B squared. I'm out of room. Okay, so there's my pattern, but can't I simplify these two in the middle? Because they're both AB. So it's 1AB plus 1AB gives me 2AB. So the pattern is a squared plus 2AB plus B squared. You will often hear me saying at the board, it's the first term squared, the product, remember, because I expanded this out, this is how we'll usually see it, the product of the two terms, a times b, doubled, and the last term squared. Okay, so learn that pattern. It makes these very simple so that you don't have to write them out. So the first one that we're doing is a binomial squared. So according to my pattern here, it's going to be the first one squared, which is a d squared, and the product is a negative 8d doubled. So negative 16d plus the last term squared, which is plus a 64. Okay, now And when I attach that negative, I'm going to wind up, when I square the negative 8, I'm going to wind up getting a positive 64. Okay, so let's do this next one here. And we have the first term squared. The product of the two terms, 5a, doubled, gives me 10a. And the last term squared gives me 25. And that pattern makes things so much easier. Okay, just letting you take notes on that. And I'll see you back here in a minute with some more. All right, so we're doing the last little stretch. We're on the home stretch here. This is another binomial squared. So we'll use our pattern. The first term squared, which is going to give me 25h squared. This product of the two terms doubled, which will give me 10hk times 2, which will be 20hk. And the last term squared, which will become 4k squared. I'm going to put that down here because I've run out of room. So tack that one right there. Okay, now we'll move on to the next one. Oh, the plot thickens. Here we have a form that we recognize, but they're doing a little twist here to make it actually easier for you to do. This is a trinomial squared, but notice that they have attached these two together in a parenthesis. So what we're going to do is we're going to use our binomial squared, and we're just going to keep these guys together until the very end. Okay, so binomial squared is the first term squared. So we're just going to write 2p minus q squared, because we'll do that in the next step. And then the product doubled. Okay, so if I multiply this 3 into each one of these and double it, let's do that in another step. So we're going to say 3 times 2p minus q doubled will make this a 6. Okay, and then the last term squared will be a 9. So now I'm going to go back and distribute all of this through, and I'm going to have this one is another one of these squared, but it's just two terms. Okay, so this is going to be first term squared, or 4p squared. The product is negative 2p, and then we're going to double it. So negative 4pq, excuse me, negative 4pq. Okay, and then the last term squared is going to be negative q quantity squared, so it's going to be positive q squared. And then when I distribute this one through, I'm going to get a 12p and a minus 6q, and then my little plus 9. Plus 9. Okay, my little plus 9's there at the end. So now we have to look through all of this and see if we have any like terms that we could put together. We've got a 4p squared, pq, q squared, a p by itself, a q by itself, and a 9. Okay, so the answer is this whole string with the 9 plus 9 tacked onto the end, and wow, none of those terms will combine. So don't forget the little plus 9 when you copy it down. All right, the next one is a binomial cubed. And a binomial cubed, we basically do it as a binomial squared times another binomial. Okay, so basically what I'm going to do is I'm going to put g plus 4. Okay, g plus 4. And now, since we have our little format for g plus 4 cubed, I'm basically breaking this up into g plus 4 times g plus 4 squared, okay? And then I'm putting the g plus 4 here, and then g plus 4 squared, we can use our little pattern. So it's the first one squared, g squared. The product is 4g doubled will give us an 8g. And the last term, 4 squared, will give us a 16. Okay, so basically this is how we have to do it. We have to kind of do it piecemeal. So now I'm going to take this one and distribute it through. So I'm going to start with my g and go to each term here. Okay, so g times g squared is g cubed, and g times 8g is 8g squared, and g times 16 is 16g. And then I'm done with the g. So then I go with a 4 all the way across. So 4 times g squared is 4g squared. And 4 times an 8g is going to be a 32g. And then 4 times 16 is 64. All right, so we're going to wind up with g cubed, and then 8g squared plus 4g squared is 12g squared. And 16g plus 32g is 48g. And then plus 64. I'll let you see that for a minute. That was a long problem. All right. So now we're going to do another problem that is really a trinomial times a trinomial, because it's 3 terms times 3 terms, but we're going to set it up in the form of a conjugate problem, because see, we have a 2a plus b and a 2a plus b, and we have a 4c and a 4c. So we have the same terms, and in between here is a positive and a negative sign, opposite signs. So now what we're going to do is we're going to play with this like it's the conjugate rule, and we can indeed group it because these are the same. And when we do that, remember what the form of the answer for conjugates was. It was the difference of 2 squares, and those squares were the first term squared minus the last term squared. So I'm just going to go ahead with that. So 2a plus b first term squared minus 4c squared is the form of the answer for conjugate problems, and we call this the difference of 2 squares. So now this one we know how to do with our square of a binomial rule, and that rule says it's going to be the first term squared, which is 4a squared, the product 2ab doubled to give me 4ab, and the last term squared to give me a b squared. And then I have to do this one, which is going to be a minus 4c squared, which will be 16c squared. And there are no like terms to combine together. So now we're ready for our last problem. This 6.4. All right, so now we've got a binomial and a trinomial. We have called the binomial f of x and the trinomial g of x. Okay, so this notation, remember, is a shortcut notation that means f times g of x, which means I have to multiply the binomial here to x minus 7 times the trinomial here, x squared plus 9x plus 2. And I'm just going to do this with horizontal distribution, which means I'm going to take the 2x and make sure it touches each one of the terms in the trinomial. So 2x times x squared is 2x cubed, And 2x times 9x is 18x squared. And 2x times 2 is 4x. Okay, so we're done with that one. Done with the 2x. So now we're going to take the negative 7 and go through each one of these. Negative 7 times x squared is negative 7x squared. I'm going to put it underneath the x's. Negative 7 times 9x is negative 63x. And negative 7 times 2 is a negative 14. So now I'm going to combine all of those together to get my product of the two. And I'm going to wind up with, I'm going to move this down a little bit, FG negative 3. And now I'm going to put this final answer here, 2x cubed. 18 minus 7 is 11x squared. And 4 minus 63 is negative 59x minus 14. Now, we have FG of negative 3, which simply means that we're going to take this product that we just did and we're going to plug in a negative 3 everywhere we see the x. So now we're going to take the I put this on a little bit cleaner board. So we are doing FG of negative 3. And this was what we just got for the FG of x. So now we're going to plug in the negative 3 everywhere. So we've got negative 3 times negative 3 times negative 3, which is a negative 27 times a 2 gives me a negative 54. And then when I take a negative 3 times a negative 3, I get a positive 9 times an 11 is going to be a 99. And then when I have a negative times a negative, it's going to be a positive, and I'm going to have a 59 times 3, and 59 times 3 is, I'm cheating, 172. I just did it on another sheet of paper. And then we have negative 3, oops, no more. We don't have an x in here, so we're just going to put down negative 14. Okay, so when we add these all up, what I like to do when I'm adding a string of numbers, and I like to add my two positives together and then add my two negatives and subtract them. So when I add these two together, I'm going to end up getting, this is almost 100. If it was 100, it would have been a 272. Since it's not quite 100, it's going to be a 271. And then a negative 54 and a negative 14 will be a negative 68. And when I subtract those, I get, I'm going to have to borrow here, 11 minus 8 is 302, which is the correct answer. Now, let's do this one other way, okay? If I had not asked you to find FG of x, you would be free to use this other way. So let's put our f of x back on here. F of x was 2x minus 7, and g of x was x squared plus 9x. And I did this for you in the classroom as well. But we're going to do it with this one. So if I had not had to figure out this whole thing, then if I asked you just FG of negative 3 and I didn't ask you anything else, you would be perfectly okay to just take the f function and plug a negative 3 in, and then take the g function and plug a negative 3 in, and then multiply them together. So basically, this is the same as f of negative 3 times g of negative 3. So we're going to do it that way, and hopefully we will end up with the same answer, which was 208. Okay, so 208 was our first answer, and hopefully we will wind up getting that one again. So now we plug in a -3 here, and we get 2 times -3 is -6, minus 7 is a -13. So -13 is what this one becomes. So -13 becomes this one. And then we're going to multiply that by g of -3, which means I'm going to plug in a -3 here. -3 times -3 is 9, plus 9 times -3 is -27, and then plus 2. Okay, so I wind up getting an 11 minus a 27, and that's going to wind up being a minus 16. Okay, so now if I multiply these two together, I hopefully will get a positive 208. I know I'll get a positive. All right, so I'm going to do that math here. 16 times 13 is going to be 6 times 8 is 18, and that's going to be 3, 4, and then that's going to be a 6, 1, and when I add that together, I will get an 8, and then a 10, and then a 2, which is exactly what I got when I did it the long way. Whew, that's a lot of stuff. Okay, so this was about function multiplication, and we had already gotten this one from another sheet. We evaluated FG of -3 by plugging a -3 into each spot that we had the x, and we evaluated and got a 208, which was correct. Okay, then we did it another way by just doing f of -3 times g of -3, evaluating a -3 into both of those, multiplying those together, and getting the same 208. And I hope you have a better understanding now of 6.4, because you have a test on this material on Tuesday. And this is Mrs. A, and may God bless your day.